Cool. Good morning, everybody. So I know Mishra beat me to it already, but I want to welcome you all officially to HashiConf 2019 here. It's super exciting for us to be back here. Amsterdam has kind of become a bit of a second home for our conference. This is now the third year that we've done it in Amsterdam. Let's see. And last year was actually exciting. We did it literally, I think, just across the street from here. That was 2016. We did HashiConf. I don't know why the clicker is stuck here. Oh, here we go. Sorry about that. Technical difficulty. HashiConf 2016 was actually the first time we did an event in Amsterdam, and it was literally at the Transformer House. And it's been fun to just watch the growth of the European user community. At the time, this was the first conference that we did in Europe, and we were sort of thinking maybe we could get 100, 200 people to show up, and we were pleasantly surprised. We had about 300 folks who made it to the first event. As you can see, we've grown a little bit since then. Wouldn't be able to quite fit into the old space. Today, there's a little bit over 790 people, 800 people joining us in total, and then another few thousand people we're expecting joining over the live stream. So what I'd encourage you to do is use this as an opportunity to make new friends, make new connections. For many of you, I think this is probably the first HashiConf. I'm curious, sort of quick show of hands, how many have ever made it to a HashiCorp event, or for who is this? Okay, so then show of hands, first conference for any HashiCorp event. Okay, so this is the first time for a lot of folks. So I'd encourage you, use this as a good opportunity, meet the new people, share ideas. I think many of you will find, maybe you've used Terraform, but someone else here has used Vault, and you can learn about that or one of the other tools. So this is a good opportunity to kind of get together and learn from folks in the community. I think what's been fun is, when we first did our conference in 2016, there were no employees based in Europe. We were probably only about 30 people at the time, totally based out of the States. And today there's now 85 European employees out of about 600 in 6 different countries. At the same time, the user community has grown even bigger than that. So one thing we like to talk about and encourage you to join is the HashiCorp user groups. These are small meetup groups that are local, they're in your communities, and they're really an opportunity to just get together on a regular basis, monthly, quarterly, and just talk about how are you using the tools, how are other people using them, what are the use cases, and it's an opportunity to network in person and get some of that sort of expertise. So these have started, a few years ago was the first hug based out of San Francisco. Today there's a little over a few hundred chapters. There's 28 just in Greater Europe in 16 different countries, and about 25,000 members around the world. Another thing that we're really proud of, we launched this a few years ago, is the HashiCorp Diversity Scholarship. I think one thing that we're sort of aware of is not everyone has the privilege to attend events like these and get to have their travel paid and their tickets paid and get to come and learn from these types of venues. And so our goal was, how do we bring in a diverse community of people who don't necessarily get to attend? So we created this scholarship to bring in folks from both regionally within Europe, but also around the world, people who wouldn't otherwise be able to attend HashiCorp events. And so you'll find people sort of among us who are here because of the Diversity Scholarship. So again, just use this as an opportunity to meet new people, not just the folks you know from other events. So with that, I want to switch gears into talking about sort of what's the HashiCorp mission? What's the kind of ethos for us? What do we sort of focus on and believe in? And I think for us, I can kind of boil it down to one common sort of view, which is our worldview is that everything is going multi, right? And when I talk about everything going multi, I think the sort of obvious one that comes to mind is the world going multi-cloud, right? This is sort of maybe the most obvious version of the world going multi. And I think this is going to not be a surprise for most of the people here. Right? I think over the last few years, we've seen the world kind of go through a few iterations of this. Right? I think cloud in its sort of single form is not really new. I think Amazon EC2 launched in 2006. And so I think we've had this notion of public cloud being around for a while. But I think the long-time view was, hey, small companies and startups, they're going to use Amazon. Large enterprise businesses, they're going to stay on their traditional on-premise. And Amazon is the sort of only cloud. And I think we've seen that evolve over the last few years, where it's not just Amazon. There's many very credible clouds, including Azure, GCP, Ali Cloud, et cetera. And I think the view from large enterprises has also changed. Right? In 2006, it was sort of inconceivable that the enterprise would use the cloud. Now I think when you talk to most large organizations, they all have a public cloud strategy and a multi-cloud strategy. Right? So everyone sort of now adopting everything. Beyond multi-cloud, our view is that things are going multi-platform. It used to be that our applications were largely homogeneous, monolithic applications running on VMs on-premise, and that's changing, right? I think a few years ago, we saw the rise of Docker, which quickly led into container management platforms like Kubernetes. And now we have applications that might span traditional VM-based infrastructure, as well as more modern Kubernetes container-based systems. But already, before we've even finished that adoption process, we're already seeing the frontier shift to serverless platforms, right? And whether we define serverless as sort of function as a service, something like Lambda, or more container as a service model with Fargate and Azure container instances, or sort of a source model like Google Cloud Run, I think broadly you can think about this as kind of a next generation of platform. So our view is that no one of these things will ever be all of your application, right? You're going to mix and match. There's some set of applications, traditional database, it's going to fit best on virtual machine. Some set of application that works best on container. Maybe your new integrations that are lightweight, those will live on serverless. So our view is all of these are going to be a part of your infrastructure. It's never going to be one or the other, right? And then the last piece of this is our worldview is that things are going multi-service, right? Historically, we might have stuck with a monolithic development pattern and had a relatively large single application. And for most users, that's still the right place to start. When you're starting a new project, it's a new company, start with the monolithic app. But over time, as the complexity grows, as the team size grows, that application is going to get split into many different services, right? So we might break up our front end from our intermediate API layers, from our back end storage layers, and this lets us sort of reuse and mix and match different functionality, right? And so as we do this, there's sort of a whole world of operational challenge that we inherit, right? Now we have to worry about how do these services connect to one another, how do we secure it, how do we deploy and manage this much more complex application, where bits and pieces of this might run on different platforms, different clouds, right? And so in our worldview, there's kind of four major groups when we think about sort of delivering an application, right? Our operations, security, networking, and development teams. And for each of them, there's a set of assumptions that changes as the world goes multi, right? I think for sort of operations, we used to live in a world which was very consistent, right? It was dedicated servers, largely physical and virtual machine. That's going away, right? Now we're going to have capacity on demand. We're not going to have 100 machines that we bought and racked and stacked. We're going to scale up and down as needed. And it's going to be a mix of different types of infrastructure, virtual, container, function, et cetera. For our security teams, there's a total shift in their model, right? I think historically the security model is what I like to call kind of castle and moat. We had sort of the front door that we brought all of our traffic over, and we put our firewalls and our web filters and our intrusion detection systems there. And we basically asserted that the outside was untrusted and insecure, but the inside was trusted and secure, right? So sort of the castle walls defended us, and we trusted everyone on the inside. But as we go through this shift to multi-cloud, multi-platform, multi-service, it gets much harder to secure that inside, right? It's not clear where the walls begin and end because I have now 5 different data centers and 5 different cloud environments. What's the front door? All of these things are connected to one another. Traffic's flowing back and forth. So as we kind of transition, we start to lose this notion of a clear perimeter. It's not obvious anymore what the traffic flows are. And so we change our security model from saying everything inside is trusted to instead we're going to assign an identity. Every application, every service has a unique identity, and we're going to use that to govern access. This is the notion behind sort of zero trust networking or identity-based networking. Then when we talk about sort of connecting these different services together, traditionally we took a very host-oriented approach, right? We had a load balancer that pointed to the set of machines that were web servers or pointed to the set of machines that were databases. But now as we sort of transition into this multi-platform, multi-cloud world, what does it mean if we don't even have a machine running behind it, right? How do I point to a Lambda, right? Maybe it's not even running. Until I invoke it, there is no IP. There is no static machine running there. So the whole notion of how I think about routing and networking has to reorient not around hosts and machine, but around logical service, right? Maybe until I invoke that service, it doesn't even exist. And then lastly, the way we think about managing and deploying our applications has changed. Historically, we thought about sort of physical dedicated infrastructure. These 50 were a web server, these 10 were a database, to now saying, you know what, I have a 100-node Kubernetes cluster. I don't really know what's running on any particular machine. It's dynamic, it's ephemeral, things move around. We're going to schedule across a dynamic fleet rather than statically managing many different smaller fleets. And so I think if you zoom out and look at the sort of cloud landscape, these problems have all been solved with a variety of different tools, right? Within each cloud, within each environment, there's different approaches to this, right? Whether, if we're talking about provisioning, I might use CloudFormation in Amazon, I could use ARM in Azure, I could use Deployment Manager in Google. Each of these provides sort of a way of doing an as-code provisioning process. But if I'm operating in a multi-cloud, multi-platform world, I don't want to have to be exposed to the sort of full complexity of this entire matrix, right? I don't want 5 different tools for the same workflow. And I think that's really the kind of ethos behind the HashiCorp portfolio, right? Our view is that these problems exist across all these environments, across all these platforms, but how do we have a kind of a common workflow, a common way of doing it, whether it's provisioning, whether it's identity-based security, whether it's networking, whether it's the way we deploy our applications, right? So that's kind of how we think about the tools in relation to each other and the clouds themselves, is it's really about providing that common way to operate in this environment. So I think one of the interesting things when we talk about sort of this mixed platform, this mixed mode, is that in some sense this is not new, right? If we go back as far as you want to go back, right, to mainframes and then scrub forward from there, you'll find organizations that still use all of these technologies, right? Go to any large bank, and at the center sits a mainframe. Around that is the bare metal. Around that is the VMs. Around that is the Kubernetes environment. And around that will sit the serverless stuff. It sort of like rings in an old tree, right? And so when you talk about what's made this possible, like how have they been able to mix and match 40 years of different technologies, it's ultimately about the fact that there's a common network, right? The new serverless application can communicate with the mainframe because they both speak TCP, right? They both get an IP address, they both speak a common protocol. And so in this way, the network has been sort of the common denominator. It's been the piece that's allowed all these technologies to interoperate and sort of shielded the fact that it doesn't really matter if one app is in a container and one app is in a VM, as long as it has a network IP and it speaks the right protocol. And so I think there's always been kind of 3 key challenges that we've pushed into our network and thought about as a networking problem, right? One of those is naming, one is authorization, and one is routing. So we'll touch on each of these quickly. So when we talk about naming, it's really about what is the address, what is the sort of logical name my downstream uses to talk to my upstream. So in this case, my downstream web server wants to talk to my upstream authentication service. What's the name that the web server uses to reach it, right? What is it hard code as the URL string? And I think historically the approach was static IP, right? So in this case, the .51 IP would be the name that the web server is using to reach the authentication service. What's common is you end up using something like a load balancer or as a virtual IP to do that sort of disintermediation. So .51 isn't actually an instance of the authentication service. It's taking us to a load balancer. The load balancer is then acting as the name, right? And it's connecting back to one instance of the authentication service, right? So this is a common problem. Another common challenge is doing authorization, right? So the way we typically see this solved is putting something like a firewall into the network in between the path. So if I want to have authorization around who's allowed to talk to this service, I might put a firewall in front of it and then manage a set of rules, right? So I can say .51 is allowed to reach, .104, and the firewall is now acting as an authorization function, right? The final piece is routing, right? And routing is sort of a big world. There might be many different reasons you're doing routing. You could either be doing it for load balancing, right? Maybe I have a lot of traffic and I need to run 10 instances and I want traffic to split across it. I could do it for high availability. So maybe I have 2 instances of my database, my primary and secondary, and I don't want to overwhelm one of them. Or I'm doing it as a failover mechanism. And the other use case might be more sophisticated things like canarying of traffic, right? So in this case, maybe I have 2 versions of my app, version 1 and version 2, and I want to send some percent of traffic, maybe 1% to version 2 to understand, does version 2 work? Are there bugs? Is it performing the way I expect? And then if that looks good, I can sort of crank up the amount of traffic that goes to version 2, right? So all of this I'd loosely put into the same category of routing. And here's where you would again see a pattern like putting a load balancer in the middle. So what this allows us to do is not burden the downstream with the logic of this sort of routing, right? I don't want my web server to have to know about traffic shifting to its upstream or dealing with multiple versions, et cetera. We sort of shield it, let it talk to the load balancer, and move that logic out of the application, right? So this is sort of common. So if we look at kind of a traditional data center, what you'd see is a very clean north-south path, right? Internet traffic comes in from the north. It flows through our perimeter firewall. This is how we make sure the untrusted bad things stay out. The trusted good things are on the inside of our four walls. From there, we probably go to a front-end load balancer, which brings us out to our web servers. They do some processing and ultimately are reading and writing data from a back-end database, right? So the back-end database is probably shielded as well with a firewall that prevents services that shouldn't reach it from talking to it, right? This is sort of the traditional data center. And here we have to probably manually manage things like our firewalls and load balancers. Now, as we sort of extend that and go to multi-data center, you might say, okay, now I have a cloud region, right, that I'm going to add onto this. That needs to connect back to on-premise with some form of networking technology, whether it's VPN, SD-WAN, dark fiber, etc. Right? There's some networking link back between these zones. And I might adopt a newer platform, right? And this goes to the sort of multi-platforming we see, is one might be my more legacy environment. One is where I'm adopting Kubernetes for my new microservices. And so there's going to be some new databases that exist in the cloud. My new services might use, key value store, might use a graph store, etc. But very likely they need to communicate back to the existing on-premise environment, right? I need to reach back to old data, old services. And so I need to manage names in a way that are portable between environments, authorization in a way that's portable, routing in a way that's portable. And this problem sort of only gets worse as we get bigger, right? The bigger we get, we start adding more data centers, sort of an explosion of network linking in between them. It's not just one VPN tunnel now. Now you end up with 8 different tunnels or 16 different tunnels as you start scaling, and even more platforms, right? So the complexity sort of grows. So it's in this environment that we really designed Consul, right? So our goal when we talk about Consul is really talking about solving the service networking challenge, right? And so these are kind of the key challenges. And so within that realm, there's sort of 2 key ways to think about Consul. One is as a traditional service registry and discovery mechanism, and one is as a service mesh. And when we talk about this, we don't think about them as being sort of a binary distinction. It's not one or the other. I think it's part of a sort of a logical maturity journey of the network, right? I think if you look at most networks, where most users start is centralized hardware, right, running on-premise with a manual process around it, right? So I file a ticket and someone logs in and updates my firewall, updates my load balancer manually. From there, I think the service discovery journey is really about automation of that process. So I can keep my centralized hardware, but now I move away from manually managing the load balancer, manually managing the firewall, to allowing it to be automatically updated based on logical rules, right? From there, as we say, great, I want to adopt a public cloud environment, I'm not going to ship my hardware device up to Azure, right? So how do I change my approach? I move from a hardware-based approach to a central software approach, right? Think about running like Nginx as your front-end load balancer instead of F5 big IP, right? So it's fundamentally the same sort of logical model. It's a centralized appliance, but we're moving from hardware to software. How do we still do it in an automated way? And I think the final evolution of that is moving away from central appliance, right? And pushing that out to the endpoints of our network and doing it with a distributed software approach, and that's what becomes the service mesh. So in this way, we don't think about it as a binary one or the other. It's part of a journey, and in fact, you're probably going to have a mix of all of these things in your network at the same time, right? So when we talk about service discovery at its core, it's really about using a name as a name instead of an IP as a name. Right? So the web server, instead of using the .52 address or the .104 address, would use a logical name like auth.service.consul. And then that's getting resolved dynamically into a physical address. Right? So in this way, we can scale up and down. We can have different IPs. If that instance fails, we can resolve it to a different node. And so it's really about sort of moving the naming function to something that's dynamic. When we talk about the network automation piece, instead of managing those sort of static firewall rules that said .51 can talk to .104, we instead manage sort of a logical rule, right? We say the web service is allowed to talk to the authentication service. The set of IPs, though, are dynamic, right? So we don't know which set of IPs are web services because maybe we're scaling those up and down. And same thing with our auth service. So what we do is allow Consul to act as that dynamic registry and knows what set of IPs are web, what set of IPs are auth, multiply those together, and that becomes your firewall rule, right? And so if I boot a new web service, I scale it up and down, I have it in an auto-scaling group, etc. Now the firewall can be updated on demand. I don't need to file a ticket and someone manually adds a new IP rule. We can sort of automate the flow in the middle of the network. And when we get to sort of the final version of this, what we're really doing is pushing that functionality to the edge of the network, right? So what we might have is something like Envoy running within our pod, within our VM, as a sidecar to the application itself. And so what happens now is the web server, when it wants to discover and connect to its upstream, it's really talking to the local Envoy instance. So the name is always local. The local Envoy is doing the routing. It's determining where's my upstream, how do I get to it, what percent of traffic should go where. And then the upstream Envoy is responsible for authorization. So when the connection comes in, it determines whether or not that client is allowed to talk to it. So in the same way, that networking, authorization, and routing function still exists in the network, it's just been pushed to the edge, right? And so sort of summarizing at a very high level, I think the goals for Consul are sort of threefold. One is to be API driven, right? We want this to be pluggable with your deployment process, your CI/CD process, the way your network should be automated, right? But we also want to acknowledge that the world is going to be multi-platform and multi-cloud. Very unlikely that you'll ever be able to standardize on one technology that's forever future-proof, right? And the other side of this is really thinking about what's the orientation of the network, right? I think, if you ask some vendors, the network is the center of the universe and everything else revolves around that. Our view is the opposite, right? The application is the center of the universe. Everything else revolves around the application, right? So how do we get the network really to be, in some sense, a detail? What we want to do is manage the high-level intentions of, great, the traffic should be allowed, or we should do a failover between data centers. And then the network should just be automated to support that. So as apps come and go, get scaled up and down, that becomes sort of a detail that gets automated away. It's not the primary focus.